In this video, we are going to look at the implementation of the iterator interface. So whenever you have a new collection, only you know how you are storing the elements in it. So only you know how to deliver the elements in the collection. So this is how you would implement an iterator. So there is a collection class, which is in blue here. So this entire box represents the Java code for a collection. So obviously, you in this orange or yellow, I suppose, box, we have the fields for implementing the collection, and there are methods at the bottom here that implement the methods for adding, deleting, etc., etc. And you might have the implementation for a single node of the collection here. And the iterator would actually be implemented as a class inside the collection. So we are having a class outside, and within that there is another class for sure for the iterator. So the iterator interface is implemented as a class inside the collection class. The reason is typically all these fields are private, or most of them are private, and you need to access those fields. For example, there might be a field to store the first element, the index of the first element, the index of the last element, the number of elements, etc., etc. Those are typically private. And if you have the iterator implemented here, you can easily access those without any issue. All the private fields are accessible from code within the class. This is within the collection class, right? This is inside the collection class, nested, but still it is inside. So it is able to access all these fields. So this is very convenient. So here is a Java version of that diagram. Let's say we have a class called a linked queue. So it is a queue implemented as a linked list. It implements the queue interface. And in Java, there is a interface called iterable. I believe it is in java.lang. This is used to specify that this collection supports iterators. This collection, when requested, will return an iterator. And the corresponding method in iterable is iterator. So an object of type linked queue can be used to return an iterator by calling this method. So this method is supposed to return an iterator object for this collection. So there are fields, as we saw in the previous slide. There is a node that represents a single node of the queue. And here is the iterator class, private class. Notice that this class begins here, ends here, and it is completely inside the outer class. So the code here can access all the fields over here, all the methods of linked queue, all the fields of linked queue are completely accessible from code here. So the queue iterator can easily deliver each and every element through the next method without any issue. So when the collection is called to return an iterator, it will create a queue iterator object and return it. And then the client will use that object to retrieve each and every element. And we have the implementation of the queue here. So the fields in the linked queue could be the head, the tail, and the number of elements. So the fields might be storing the first element, the last element, and the number of elements. And the first element is a node object, the last element is a node object. So the type here for head and tail is node. This is the number of elements. Node will have, you have seen this in data structures. Node will have data and a next field, and you have a constructor that stores the data and the next field, and we have getters and setters. We have code for removing an element from the linked queue. You should be able to see how this code works from your knowledge of data structures. So I'm not going to get into the details of this. Let's focus on queue iterator. Even this you must have seen in a data structures class. Private class queue iterator. I made this class private. The reason being, no client needs to know the exact name that the iterator class is using. They get the iterator through the iterator method, not by saying new queue iterator or anything. We want to hide this. This is a very good way of encapsulating the information. We don't want to divulge anything more than what should be made known to others. So private class queue iterator implements the iterator interface, which is in java.util. And let's look at the code here. What am I doing? The field head in linked queue is storing the reference to the first element. So when an object of type queue iterator is created, current is pointed to the first element of the queue. And as I deliver more and more objects, current will change, and eventually current would become null, which means there are no more elements to be delivered. So has next, is there one more element that I haven't returned to the client? So if current is not equal to null, then has next returns true. And if current is equal to null, has next returns false. So as long as current is pointing to a valid object, a non-null object, it returns true. Next, if there is one more element that I have not yet returned, I will get the data from that and return that data and change current to current dot get next. That is, I move the current to the next element in the list. I advance current, and eventually this will become null, and has next will return null. And if there is no element to be returned, I could return null, or I could say throw an exception, no such element exception. And here is an example of using an iterator. Collection equals new linked list, add a couple of things, and you can use an iterator like this. Collection.iterator returns an iterator 1. Oops. And as long as there is one more element that I haven't looked at, I haven't been delivered, I will get it through next. And then I am using a second iterator. This is not doing anything specifically except to show you that you can have multiple iterators created on the same collection, and they can be at different parts. So for each element here that I get through iterator 1, I am going through all the elements using iterator 2. So nothing very deep is going on except the message that there can be multiple iterators open at the same time, and they can be looking at different parts of the collection.